Okay, we're going to move on to the last section now. That'll be on the exam 3, and that is 10.6, which is called Literal Equations and Applications. So a literal equation is an equation with more than one variable. So everything we pretty much have been dealing with so far, we've only had one variable inside the equation. Now we're going to take a look at an equation that has more than one. Now a formula is a special equation that expresses a relationship between variables. So a formula is an example, specific example of a literal equation. So formulas that you may be familiar with. Now you could or could not be familiar with these, but let's see. How about a square? What if I take a square where every side is the same? Let's call it x, 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 x. So one thing you might know is that the perimeter of a square is 4x. That's just the distance to go around this square. It's just add x 4 times. So this is an example of a formula. The area of a square is these two sides multiplied. So x times x, which is x squared. That is another example of a formula. But both of these are not only formulas, they're also what we call literal equations because they have more than one variable. The first one has p for perimeter and x, which is the length of the side. The second one has a for area and then x, which is the length of one side. So each of those equations involves two variables. We may have more than two, but a literal equation is any equation that has more than one. So when we're looking at literal equations, sometimes it's necessary to solve for a particular variable in that equation. So for example, if we take this equation, p equals 2l plus 2w, that has to do with a rectangle. We look at a rectangle, not a square. Then if we call this side L and this side W, then the perimeter is, well, let's see, this opposite side is L, this is also W. If we wanted to walk around this thing, we'd have to go L first. Okay, so we would have to go L, plus, then we'd have to go W, plus, then we have to go L again, and then plus W again. And if we put the L's together, combine them, we get 2 L's, and if we put the W's together, we get 2W. And so our perimeter for a rectangle is always going to be 2L plus 2W. So that is a formula. And sometimes we want to know if we can't rewrite that and solve this literal equation for either L or for W. Right now, the literal equation is solved for P. So because we have P by itself on one side of the equation. But what we want to be able to do is try and solve this for L or for W. So let's try doing both. So I'll do two different problems here. I want us to solve P equals 2L plus 2W. Solve for, let's go with L first. So what we want to do is get L by itself. So we want to get this term by itself. So we're going to do what we did in the past when we had equations. We're going to get that term by itself by subtracting 2W first from both sides. Excuse me. So on the right side, the 2W goes away. All we have is 2L. But on the left side, we actually have to subtract P, take away 2W. And because we don't know what those values are, they're variables, we're just going to write down P, take away 2W. And that's it. There's no way to combine those together. They're not like terms. All right, so we've got 2L by itself, but now we need to try and get L by itself. So let's get rid of the 2, and since 2 is being multiplied, I will divide both sides by 2. So I divide the whole left side by 2, and I get P minus 2W, all of that over 2 equals L. And now what I have is a new equation, but it's solved for L instead of P. Now we could start this problem over again, and we could say solve for W instead. So now we're trying to get the 2W term by itself, and we're going to follow the same format. We're going to subtract 2L this time on both sides. On the right hand side we just get 2w, but on the left hand side we get p minus 2l. Can't put those together because they're not like terms. And then again we will divide both sides by 2 in order to isolate w and get it by itself. So w here, and then p minus 2l over 2. So that is a new equation, or a new formula for w. So from an original formula, p equals 2l plus 2w, because there were 3 variables in this literal equation, I have 3 different versions of that formula where I've solved for either p, l, or w. And all of those formulas are basically the same relationship, but they're used in different ways. So like, for example, on Formula 1 here, if you know the length and the width of a rectangle, then it's easy to find the perimeter by just using this formula. But on Formula 2, let's say you know the perimeter and you know the width. Well, if you know that, you can calculate this side and that'll give you the length. On the third formula, if we know the perimeter and the length, then we can calculate this and easily find out what w is. So it just depends on what's given to you, which one of these 3 formulas is most useful. Okay, let's take a look at an example here. Well, you know what? We don't need to do that one. That's all right. Let's do these examples. Okay, so this first one here. Here's our literal equation. Has 3 variables in it, d, r, and t. We want to solve it for t. So d equals r times t, and we want to solve it for t. So we want to get rid of the r that's in front there. It's being multiplied, so I'm going to divide both sides by r. And that means d divided by r is equal to t, because the r's cancel. And so now what I have is a new formula for t. Okay, let's look at the next one. We want to solve this for v1, which is right here. Okay, and so what we're going to do, let me rewrite everything. I get p sub 1 times v sub 1 equals p sub 2 times v sub 2. I'm trying to solve for v sub 1. So that p sub 1 is being multiplied in the front, so I'm going to divide both sides by p sub 1. Divide this side by p sub 1. They cancel here. I get v sub 1 equals p sub 2 times v sub 2 over p sub 1. And now I have isolated v sub 1, so I am done. New formula for v sub 1. All right, this next one is a little weird. We have an equation, has 2 variables in it, and we want to try and solve for x. So I'm going to try and first get that term by itself. So let me try and work with it just right here. I'm going to subtract 3y on both sides. The 3y's cancel. I get 4x equals, now I'm going to have 9, and I'm going to take away 3y. I can't do anything to that. That's not 6y, okay, because those are not like terms, so I just have to leave it like it is. And now what I'm going to do is try and get x by itself, and since that 4 is being multiplied in front, I'm going to divide both sides by 4. So we get x equals 9 minus 3y over 4. I should also point out at this point that if you ever see a fraction like this, and you have 2 terms on the top and 1 term on the bottom, then you can split this up into 2 fractions. 9 over 4 minus 3/4 y. So you're basically putting this 9 on top of the 4, and that creates the first fraction. And then you're going to put this minus sign between them, and then you're going to put this 3 over the 4, and that'll create your second fraction. And then you tack the y onto the end. That'll become useful later. All right, last one. We've got our equation here, p equals 2 parentheses l plus w, and we want to try and solve this for l, right? So right now, the problem that we have is those parentheses. We cannot move this w over to the other side because there's a parenthesis in the way. So what we will first do is use our distributive property to multiply the 2 through. So we get p equals 2l plus 2w. And that should look familiar. We worked with that formula earlier. But we're going to try and isolate our l term here. So we're going to subtract 2w from both sides. The left side is p minus 2w. The right side is just 2l. And finally, we will divide both sides by 2, and that'll leave us with P minus 2W over 2 equals L. So that example is just to show you how we can use the distributive property to get L by itself. Okay, here's some group work. I can give you a moment to do those on your own, but pause the video and try it. I'm going to go ahead and start working these. Okay, so for the first one, we're trying to solve for L here, and keep in mind that in this equation, it's V equals L times W times H. That's what the formula is. Those are multiplications. I have L here. I'm trying to get it by itself, so I'm going to divide both sides by W times H. So W times H on both sides. The W's cancel, the H's cancel. We're left with just L on the right side. And on the left side, we have V equals W times H. Ooh, that's not good. Times H. There we go. Okay. Second problem. We're trying to solve for B. So we're trying to solve for that. And keep in mind here that we have addition between everything on the right-hand side. So that means we need to subtract some things. So I'm actually going to subtract A and I'm going to subtract C from both sides. Subtract A and subtract C. So on the right side, they just go away. I'm left with B. And on the left-hand side, I had the P that I started with on that side, and I'm taking away A and taking away C. And that's it. I've solved for B. Okay, so let's look at this next formula here. We want to solve for H. And when we look at that formula, it's V equals, that is the number pi, that's the symbol for the number pi, times R squared times H. And we're trying to solve for H. Oops. We're trying to solve for H. So I'm going to get rid of the pi and the R squared because it's being multiplied. I'm going to divide by pi, and I'm going to divide by R squared. But I have to do the same thing on the other side. The pi's will cancel, the R squareds will cancel, and so all I get is the left side. V over pi times R squared equals H. Okay, last one here. We're going to solve for A right there. This one's going to be a little tricky. Q equals A minus B over 2. Okay, so the first thing I want you to notice is that we've got a fraction. We've got this whole thing over 2. Now, I would like to get rid of that 2 so I can start trying to get that A by itself. So what I'm going to do first is I'm going to multiply the left side by 2 and the right side by 2. And what happens is the 2's over here on the right cancel, which leaves you with just the A minus B. And on the left-hand side, we have 2 times Q. And now we're trying to get A by itself, but we have a minus B there. So I'm going to add B to both sides. The B's cancel, I get A by itself, and this one right here becomes the 2Q that was there, plus the B. And that is it. We have solved that for A. Okay, so in the next section, as we move on in this class, we're going to be dealing with this equation right here, and I want you to understand that that's a literal equation. It is got, what, 4 different variables in it. Has y, has x, has m, has b. So that is a literal equation. We need to be prepared to solve for any of those variables. So for the next example, what I'm going to do is take this equation right here, and I'm going to try and solve it for y. Okay, so I'm going to try and get y by itself. So to do that, the first thing I'll do, let me rewrite it, 15x plus 3y equals 6. So if I'm trying to get 3y, or trying to get the y by itself, I'm going to try and first get that term by itself. So I will subtract 15x on both sides. 15x's cancel, I get 3y equals, now on the right side, I have 6 take away 15x. And so I have one more step. I've got to get the y by itself, so I need to divide both sides by 3. So I want to do this a little different on this problem. What I'm going to do is, even though I'm going to divide the whole thing by 3, I'm actually going to split it and do each of the terms divided by 3. And I did that earlier, but now you can see why it's useful. 3's cancel here, we get y equals 6 divided by 3 is 2, and then 15 divided by 3 is 5, so I have minus 5x. And one more thing I'm going to do here, I'm just going to rearrange this equation. So I'm just switching where these are positioned. I'm putting the minus 5x in front and I'm putting the positive 2 in the back. And when you look at this, this right here looks like this equation up here. We have y equals mx plus b. So we have y, we have x, and then notice that the m is negative 5 and the b is positive 2. So we will be using that in the next section, so I just wanted to point that out right now. That's why I changed this answer over to this one, so it would look like that equation up top. Okay, so group work here. Go ahead and try that yourself. I'm going to pause my video for a second. Okay, all right, on this one we're going to be trying to solve for y. On both of these problems, solve for y and then write our answer in that form. So let's try and get this y by itself. So first thing I'm going to do is I'm going to take away 10x on both sides. 10x is canceled, I get minus 25y equals 75 minus 10x. Then I'm going to get the y by itself by dividing both sides by 25. And again, I'm going to do minus 25 minus 25. Minus 25's go away. I get y equals, now 75 divided by negative 25 is negative 3. And then be careful on this one. We're doing negative 10 divided by negative 25. The most you can do is reduce this. 5 goes into both of those. So we should have negative over negative is positive, so we don't need to worry about the negatives. 5 goes into 10 twice, 5 goes into 25 5 times. So this is now going to become plus 2 over 5x. And then last step is to rearrange it so it looks like y equals mx plus b. Here m would be 2/5 and b would actually be negative 3. So that would be what m is, and that would be what b is. Okay, let's look at this next one. So I'm trying to get y by itself, right? So first thing I'm going to do is I'm going to add 6x to both sides. 6x minus 6x go away. I have 18y equals negative 9 plus 6x. Now to get the y by itself, I divide both sides by 18. And I'll just get y equals, and then here that fraction reduces, 9 goes into both of those, and I will have a negative answer. So 9 goes into 9 once, so I have minus 1 on top, and 9 goes into 18 twice. And then 6 over 18, I can reduce that. 6 goes into 6 once, and 6 goes into 18 3 times, and we have x. Last step, rearrange it, positive 1/3 x minus 1/2. So for us here, m is 1/3 and b is negative 1/2. Okay, some applications here. Roxanne drove from her home in San Antonio to her cousin's wedding just north of Dallas. The total distance she drove was 325 miles. If she drove that at an average rate of 65 miles per hour, how many hours did it take her to get there? Use the formula distance d equals rt, r times t. So this is the formula distance equals rate times time. That's what d, r, and t stand for. D equals r times t. So we know her distance she traveled. Well, let's do it this way. We want to know how many hours did it take her to get there. So we want to know how much time it took, right? So if we want to know how much time it takes, what we can do is we can divide both sides by r, and get a formula for time. D over R equals T. Now, we know what D is. D is 325 miles. And we know that the rate that she traveled was 65 miles per hour. So if we plug into this formula, time will be our distance, 325, divided by 65, and that should give us how much time it took her to get to Dallas. That should be 5 hours. Okay, so let's look at this next problem. Mr. Smith invested $15,000 into an account that pays simple interest. If the total interest after 12 years was $5,760, what was the interest rate for the investment? Use the formula I equals P times RT to solve the first. In this formula, to solve for R first. So what they're telling you here is that we have a formula, I equals P times R times T, where I is the initial amount, or the interest, I'm sorry, the interest rate. Okay, so I is the interest. That's not rate, that's the interest. And then P is the principal, that's the invested amount. R is the interest rate, and then T is years. So we want to first solve for R. Okay, so let's solve for R. So all we have to do to solve for R is divide both sides by P times T. That'll kill the P's and the T's, and I'll be left with R equals I over P times T. Now let's see what we know about R. Do we know how much interest she received over this 12-year period? Well, yes, the interest was $5,760. Okay, do we know the principal? Do we know how much was invested initially? Well, yes, $15,000. Times T. Do we know the time measured in years? Well, yes, 12 years. So we put 12 here. So now what I'll do is I'll go on my calculator and I'm going to multiply the bottom first, 15,000 times 12, and that's going to give me, 180,000. And now I will take 5,760 and divide it by that, and I will get 0.032. That's our interest rate. And if you wanted to, you could rewrite that as a percentage by moving the decimal 2 places to the right. Remember, that's how we convert decimals to percentages. And that would give us a 3.2% interest rate. Okay, this should help you with your homework. Hope it goes well.